This is part 2 on Proteus circuit simulation. In this video, you're going to learn how to find the current and voltage in a simple circuit. You will learn how to use the DC ammeter and DC voltmeter and how to change the properties of the components. So I'll be using this simple circuit. I have got a battery source connected to two resistors in series. It's very easy to find the current from the battery. So the current is voltage divided by the total resistance. Because the resistors are in series, you'll have 8 plus 2, which is 1 amp. And the voltage across resistor R1 is the current through resistor R1 times the resistor, which is 2 volts. And the voltage across resistor R2 is the current through that and its resistance 8 volts. The parts you require to build the circuits are you need a battery source and you need 2 resistors. Because we want to find the current and the voltage using the Proteus software, you also need 1 ammeter and 2 voltmeter. And this is how we are going to connect the ammeter, which is in series, and the 2 voltmeter across these 2 resistors. So you just have to remember this simple tip you might have already know. So the current direction is from the positive of the battery, and when it flows through any resistor, so we assume that the current flows from the higher potential towards lower potential. So when the current flows through the resistor from left to right, the left hand is more positive than the right hand. Similarly, in the resistor R2, the current flows from top to bottom, so the top will be at higher potential than the bottom. So we show that as a plus and a minus. So plus means a higher potential and minus means the lower potential. I've started a new project. We have seen how to create a new project, and I'm going to click on this pick list. First, I'm going to add the battery. So you can choose this battery device. You can also choose this cell. Let's choose the cell. So I don't have to click OK here because I have to add more components. I can just double click. So you got this cell added to your project. Now I need a very generic resistor. Just type RES and choose this the generic resistor symbol. Double click, it adds to. So yeah, so we need to add the ammeter and the voltmeter, which you can do from the virtual components, the virtual instruments here. So this you can drag and drop into your worksheet. So go back here. So I'm going to bring the cell first. So click on the cell. Now when you click first time, you get this the battery symbol. So you can decide where you want to place this. So then click again, you get that is placed. You can zoom a little bit, and also you can center your workspace by using this the green rectangle. Click. So I'm going to bring 2 resistors. So one I'm going to place here. I'm going to make some more space for the ammeter. The other one I'm going to place here, but I want this to be in the vertical orientation. Right click and rotate clockwise. Now by default you can see the resistors are set to 10K and 10K. Now we have to change that value. So we wanted the battery to be 10 volts. So just double click and set the voltage to 10V. And click on this 10K and set the resistors to 2 ohm, and this one set this to 8 ohms. So we got resistor with 2 and 8, and we need an ammeter in series with the battery and the resistor. So go to the virtual instruments and bring the DC ammeter. So click once and you can choose where you want to place. So this should be alright. Click and you can start building up the circuit now. So you need a voltmeter across these two resistors. So one, click here, click one here, and you need one more on the top. So I'm going to make some more space on the top. So you can click and you can use this right click and say drag, and you can get here. I'm going to rotate this anti-clockwise, so rotate anti-clockwise, and you can move a little bit. So you got all the components placed. So make sure the positive of the voltmeter connects to the positive end of the resistor, because you know the current flows from the positive of the battery and it enters through ammeter again, because current is entering from this end, so this is more has a higher potential than the other end. So connect here, connect this end to this, and same as I'm going to connect here. So we got the entire circuit done. We are going to simulate. Now to simulate, you're going to use this the play button in the bottom left corner. So if you click, you can see that the ammeter shows the current as 1 amps, and the voltage across this resistor is 2 volts, and the voltage across this is 8 volts. So you can stop the simulation, stop it, and if you want to send this to a friend or submit, I mentioned in my previous video, you just have to take a screenshot, because the demo version of Proteus doesn't allow you to save the project. Now I'm going to simulate again. Now assume that you want to change the value of the resistor. So if you double click now, you get a warning that says simulation must be paused to change these parameters. So you have to hit this the stop button. Now we can change the value of the battery or the battery resistor. So let's change the value of the battery to say 5 volts and simulate again. Now we get a different voltages. I'm going to change the value of the resistance now, so you have to pause it or you can stop. So double click, I'm going to change the resistance to 100 ohm and the resistance of this one to say 500 ohm. And I'm going to play. Now you can see that the ammeter shows the current is 0, whereas we still have got some voltages across these two resistors. So you know it's not possible. So what we have to do now is the ammeter is set to show the current in amperes. Because now we have got a higher resistor, the current will be in milliamps. So you have to change the settings of this ammeter. So I'm going to pause for a while, double click. You know it's set to amps, set that to milliamps and say OK. Now back to run the simulation, and now we can see the current is 8.3 milliamps from the battery, and similarly you can find the different voltage drop across these two resistors. So now we know how to use the ammeter and how to use the voltmeter. So you can apply this knowledge to any complex circuit. I'll take one more example to make sure you understand how to measure the current and voltage and draw the circuit diagram. If you already know how to draw these type of circuits and find voltage and ammeter, you can skip this rest of the videos. So what I have here is a typical circuit given to students to find the current and voltage across various resistors using the Kirchhoff law or using the mesh algorithm. So I'm going to go through this circuit diagram so that we understand, and also so we know that how to place the ammeter and the voltmeter. When you try to solve these type of problems on a paper, so we always go with the assumption of the current direction. I have got two battery source. I'm assuming that the current coming out of this battery, 10 volts battery, is I1. So it's going here this way. It enters through the ammeter and it enters through the resistor. Now wherever the current enters, that will be the higher potential. So I have shown this as a plus and minus. And here also in the resistor R1, the current enters at this end, so I'm showing this as a higher potential, plus and minus. Now when you connect the voltmeter across this resistor R1, so we have to make sure the voltmeter positive is aligned with the positive of the resistor. Similarly, from this 20 volts, we're assuming the current is I3. So we have got an ammeter, so we got the plus of the ammeter here and the minus in there, and the current enters the resistor R2. Again, since the current is entering from the right to left, the right hand of the resistor is positive or higher potential than the left hand. So we have to make sure the voltmeter also matches this polarity. The plus of voltmeter connects here. Now in the branch, I'm assuming the current is I2 flowing from top to bottom. So again here, the positive of the ammeter, because the current enters from the top to bottom, the positive end is always on the top and negative on the bottom. Across resistor R3, you got plus here, the current entering R3, and minus here. And also the voltmeter is connected with the polarity plus and minus as shown here. So what I did now is went to edit and chosen select all objects. I have deleted everything. So you got a clean worksheet here. You can always press an escape key to get rid of this unwanted drawings. So I'm going to start drawing the circuit diagram. I need two voltage source, so I'm going to click. So I'm going to also change this at the same time. So I need this. So if you notice here, I just clicked on the name, so you can just change the name, the battery V. So I need either I click on the value 1.5 volts, or you can click on the symbol itself. So I'll click on the symbol. I'm going to make this as 10 volts, and I need one more battery. I'm going to draw on this end for the time being, and I need this to be 20 volts. So next on the path we need an ammeter. So go to the virtual instruments, which is here, and bring the DC ammeter and draw here. Now since the current enters from here, we already got the positive of the ammeter in the right direction, so just make this connection. On other end we need a resistor R3, so go to your components and bring the resistor and double click. I want this to be, it's not the string, you just have to click the resistance. I want that to be, sorry, I didn't show the resistance there. I want that to be 1K, and I want this to be 1K, and I think the other one I wanted that to be 2K, and the other one is 5K. So sorry, I forgot to mention that on the diagram. So I'm going to connect these two, and I need one more resistor, or we can make we can place an ammeter on this side. So go to the virtual instruments, take the DC ammeter and place here. Now I want this ammeter positive to be connected here, so you can rotate this anti-clockwise and you can move. Yeah, so this should be alright. Probably it looks better if you can move this down a little bit and bring the ammeter down as well. So I'm going to connect these two, and I need a resistor here. So go to the resistor, click. I'm going to connect this and here, and you need to connect these two as well, and you need 2 voltmeter across this. So because the current enters from here, this end of the resistance is the higher potential than this. So go to your virtual instruments and bring the DC voltmeter. Now you can rotate this anti-clockwise and move here and start connecting from here and from here. You need one more, click again, and you want, so if you remember, the current enters from here, so this end of the resistor is positive, so I want to rotate this the clockwise, so clockwise, and then take it to where you want and connect. So we got there. Now we need an ammeter for the branch, so go to the DC ammeter, click, and I'm going to rotate this clockwise again and connect this end to here. After this we have a resistor. Go to your resistance. Now I want to make this vertical, so rotate clockwise. Now bring it here and connect these two. So you can also complete the connection from here. If you're inserting the voltmeter in across, make sure you got more space here. So connect this, this, and that, and go to your virtual instrument, bring the voltmeter. So this is in the right direction because the current flows from top to bottom, so all the upper end of the components are positive or higher potential. So connect this to here and connect this to here, and I need this one to be, just double click on here, so the resistance I want that to be as a 2K, and I want this resistance to be 5K, 5 and K, and otherwise, so if you look at these, the values of the resistance and the voltages, looks like the current flowing in the circuit will be in the order of milliamps. So I'm going to change the property of the ammeter to show milliamps, not in amps. Otherwise you will end up seeing a 0 amps in the ammeter. Milliamps. So we got our circuit done. So we just have to, you don't have to worry too much about the plus and minus in the circuit, because if you see a negative value for the voltage and current, that tells you the current will be in the opposite direction than what you assumed. So I'm going to simulate, hit the play button. Now you can see that, so there is a 0 amps here, this is 0 amps. You can see the current from the battery, 20 volts battery is 4.12 milliamps. We got a positive, that means the direction of a connection is, assumption of the current is right. And here also the voltage drop is 8.24 is positive. And what about here? The current, we assume the current is flowing from this direction, but the ammeter shows it's a negative. So looks like because of the 20 volts, looks like this battery itself is driving the current for the entire circuit. So this tells you that the current is not in the assumed direction, whereas it's in the opposite direction. So you can go back, we're going to do that now. We can go back and change this the connection and make positive here, negative here, and same here also. It's showing the voltage drop across R1 is 1.76 but negative, so it could be you have to change the connection of this voltmeter. So here you can see the current is 0, whereas the voltage is 11.8 volt, which is not possible because you cannot have a 0 current and a voltage of 11.8 volts. So if you come across a 0 here, it means we haven't changed. It's very obvious from this diagram. We got MA, this is set to milliamps, where it's set to amps. So to make a change, if you try to double click, you will get this warning so it says you have to stop. So I'm going to stop this thing, double click the ammeter, change this to milliamps. Okay, now run. You can see there is a current of a plus 2.35, and our assumption of the current from top to bottom is right because you're having the positive sign here. We just have to go and change the connection of these two. So we're going to do that now. So stop this thing. The best thing is just go and delete that. That's easy rather than playing with this connecting wires. So go to DC voltmeter, click here. So click, and so it is positive on this side. So I'm going to rotate clockwise and connect from here to there and here to here, and go to DC ammeter, click here. So we need positive on this end, right click and say rotate clockwise, and one more clockwise. So connect from here to here and here to here, here to here, and don't forget to change this to milliamps and run the simulation. So you can see everything is positive, and this tells you the current is flowing from right to left. So I think that's all in this video. I hope now you know how to use ammeter, voltmeter, and how to measure the current and the voltages across various components. Thanks for watching.